in this video, we are going to take a look at normal distributions. So we've looked at standard deviation, and that's really what normal distribution is going to be based off of. So if you think about what a normal distribution is, these are two different scenarios. We take a look at this normal curve. We call it a bell curve, and that's our mean. So if someone ever says there's a normal distribution or it's a bell, what that means is half of the data is on one side of the mean, and the other half of the data is on the other side of the mean. Now, it gets even more specific than that. We can start breaking down these topics based on our standard deviation. So if this is our mean, we are going to look at one standard deviation above our mean, one standard deviation below our mean, two standard deviations, etc. So this spot right here says my mean is then plus one standard deviation away. And then this one here is my mean plus two standard deviations away. So it's breaking down each of these pieces. So if it says you're within one standard deviation of the mean, it means you're in that interior region. On both sides, one standard deviation above the mean and one standard deviation below the mean. So you're close to the average, possibly a little bit above or a little bit below. If you fall within one standard deviation of the mean, you fall in the 68%. 68% of the entire population falls within one standard deviation above and below the mean. And this starts to get into standardized testing. You'll hear oftentimes you fall in a certain percentile, or you're a certain number of standard deviations above or below the mean, etc. So that's part of where this data comes into. It's taking a whole group and looking at this normal standard distribution. Now, this doesn't always work perfectly. In today's video, we're going to look at if this was perfect, if we had exactly this percent of people within one standard deviation, two standard deviations in a normal setting. The next video we're going to look at is what happens if that's not the case, and then we have to standardize it so it does fit this perfect shape. So getting into the nuts and bolts of it, if we're looking at the area under a curve, because that's what we're taking a look at, is this entire curve of all of the people that fit in this data. There's that mean of x bar, and your standard deviation has the following properties. So that entire area under the normal curve is 100%. Every single person fits underneath this curve. 100% of the people are there. And then within one standard deviation of the mean, so that's that red part that we had in the previous slide. So within one standard deviation, 68% of the people fall. Quite a few people fall underneath there. And then within two standard deviations away, so that goes out to two standard deviations. Within two standard deviations, 95% of the people fall. And then lastly, within three standard deviations, so that's all the way out to those spots there and up, that's 99.7%. That means not quite everybody fits within three standard deviations. That means I have some people on the ends, specifically 0.3%. So this portion right here is 0.15%, and this portion right here is 0.15%. So we're going to go back to this shading region here to help you kind of see it. So if I were to take a look at this, maybe I say my inside are my C's. So within one standard deviation, you get a C on that test. And then if you're above one standard deviation but less than two standard deviations, you're going to get a B. And if you're more than two standard deviations but less than three standard deviations, you get that A. That goes the opposite direction too. This is my D. This is my F. Well, but there's still that amount that sits above and below these parts. Maybe this is greater than 100%. And maybe down here, this is going to be less than 50%. So that's what falls within there. Now, think about it. Sometimes there are grades that are above 100%. And yes, you do have grades that are below 50%. A small amount. So the next time you say, I want a curve on this test, okay, 68% of you will have C's. Are you okay with that? No. And however many A's I have, That's how many F's I have. Are you okay with that? Equal B's and D's? Grades start shifting around a lot. This is a curve, specifically a bell curve. Now, breaking each of these spots up, I did my large percentages. Now let's look at each of the individual pieces, because we will look at just falling within certain regions. I want to know what happens if I'm 1 standard deviation above the mean, or if I'm 2 standard deviations above the mean. What percent total am I at? So I'm smarter than how many other people if I fall at this specific spot. And we can only look at these specific spots. We can't look at the in-between pieces until we start looking at a standard normal table. So this is part of what we're going to be looking at is, hey, I fall 2 standard deviations above the mean, which means I am smarter than all of these other people. Or, on the other end, if I'm 3 standard deviations below the mean, I'm smarter than those people. Or there's 99.85% of the population who scored better than me on that. So these are the parts that we're going to look at. We're going to draw lots of pictures, and we're going to be marking off our standard deviation so I can get the exact percentages that I'm going to fall in along the way. Because I'm not just going to ask for this specific region. I may ask for these 2 regions. And you're going to have to figure out, okay, where does that fall based on some story problems. So here's our first story problem, using words but has no true meaning. A normal distribution has a mean of x bar, standard deviation. For a randomly selected x value from the distribution, find the probability that my x value is greater than or equal to my mean. Here's my mean, but less than or equal to my mean plus 3 standard deviations. Here's my mean plus 3 standard deviations. I'm drawing you a picture this time. I'm not always going to draw you a picture. So you know your probabilities as approximate as possible, but as close as possible. 34% is there. 13.5% is there. And then 2.35% is here. So when I add all those up, I get 49.85%. That's the hard way. Think about your mean. This is halfway. 50% of my people fall on one side. I know this leftover part, more than 3 standard deviations away, is 0.15. So 50% minus 0.15. So all of these are just different ways to figure out what your probability is, so that you can figure out exactly what your percent is according to our values. You will need to know those percentages, or you need to know your breakdowns. Either way you want to go through it is fine, but you do need to know what these approximate percentages are so that you can answer our questions. Next one. So take a moment, pause this, draw yourself a picture, and then figure out what your probability is. So it's in this region here. That is between 2 standard deviations below the mean and the mean. So I can add up those 2 probabilities. And when I add up those 2 probabilities, I get 47.5%. Or, again, you could do the complement to it of the 50% piece. Add those 2 up and subtract from 50%, your choice. Next one. Now we're getting into some story problems. And now we're going to actually start putting some numbers on our tables. So we have a group of women normally distributed with a mean of 172. So the very first thing I'm going to do, I'm going to draw my picture, and 172 is my mean. So that has to go in the center. And then the standard deviation is 14 milligrams. So what that means is 1 standard deviation away is 14. So when I draw my first line, my mean is 172. Therefore, my next line is 186. And then 1 standard deviation below my mean, therefore, is 158. And I can keep going with each of these values. Now, in part A, it asks what percent of the women have a reading between these 2. I've already drawn enough on my graph. This is within 1 standard deviation, which makes my answer to part A 68%. Now, I could keep going and do more standard deviations, so add another 14, which would take me up to 200, subtract another 14 if I needed to go in the negative direction, which would give me 144, and keep going. However, I only needed within those two amounts. So I'm telling you what a physical standard deviation is. So instead of saying I am one full standard deviation away, I can now start bringing in some real numbers. This is what the standard deviation represents. Now in part B, it says readings higher than 200 are considered undesirable. So about what percent of the readings are undesirable? So again, I'm going to draw my picture. And then I'm going to shade in from higher than 200. So this tail end is undesirable. So a couple of ways you can think about it is I know that this is more than 2 standard deviations away. So I can figure out what 2 standard deviations, greater than 2 standard deviations is on up. Or I can think about the fact that I know what this is and subtract it from 50. Whichever way you want to do it. But then B is 2.5%. So what percent of the readings are undesirable? So 2.5% of women have an undesirable cholesterol reading. So again, just based off of this information, knowing what my standard deviations are. At this point, I cannot take a look at what would happen or what would the probability of being at 190 be. Because I don't know what 190 is. I know what 186 is. I know what 200 is. I know where they fall in terms of my standard deviations. So these have to be exact values along the way. So next one. Pause this for a minute, and I want you to answer both part A and B. So for part A, between 518 and 746, that's 47.5%. And less than 404, that's 1 standard deviation below the mean and beyond. So this part here was 34%, excuse me. Therefore, this is 16% that's left over from there down. So one last practice piece. Folks seem to struggle when I start looking at inequalities and talking about standard deviations, above, below, etc., and a certain number of standard deviations above and below the mean. So take a moment, answer these 6 questions. I'll pop the answers up all at once. Take a look at each one along the way. Draw your pictures as need be so that you can see exactly where they fall. So here are my answers for each of the individual pieces. You are, again, going to need to know these breakdowns. So if you need to, take a look at each of these breakdowns and see what's taking place. I could have definitely gone from 2 standard deviations below to 1 standard deviation above, just knowing how to break apart those percentages. You are responsible for knowing these percentages. So please get these memorized. Either know the 34% or know the whole thing is 68%, and then you can take half of it. Okay, that's a little bit big. But go through and make sure that you can incorporate each of the individual percentages so that you know each of the individual standard deviations. Right now, you are very limited to having to fall exactly on a standard deviation. In the next video, we'll learn how to work with when they're not an exact standard deviation away.